talk about your flagship dry fiber machine initially, which is the DFM 100. So let's talk a little bit more about that in terms of from an engineering perspective on the shop floor. So obviously cycle time is a well-known term throughout engineering and manufacturing. So the cycle time, how is that different, or how is that in a competitive way as good or better than other forms of forming?
Well, cycle time, of course, is one key factor for high productivity and production efficiency, and also for the cost point, because you have an invest into the machine, which is you can say kind of similar to a thermoforming machine, tool and machine equipment. And then cycle time is about productivity and output of the machine, and we have multiple tooling setups. We try to raise the cycle number with a DFM 100 machine to an industrial capable process level. And then, of course, it must be about total cost of ownership. It's not only the machine and tooling and the output, it's also the material cost and labor effort you need to drive the machine. All of these things matter. And this is what we try to achieve with our long-term experience in packaging. We try to deliver a solution to the customer which can be used in an industrial environment, which is also what the customer can earn money with, and what's working for their scenario of processing.
I see that as quite a unique advantage for ILLIG, because we are a typical machine builder, because we have been in thermoforming, we've been in packaging for such a long time. We have that experience of what it takes for customers to benefit from the machine manufacturing side, from the production side of things. So the fact that we're bringing that into the dry fiber, where some of the market out there is coming from sort of the development side of things, not necessarily from the machine side of things. So that's a bit of a unique thing from us. I also think the dry fiber for ILLIG solution, if you look at the world and the circularity and the need for sustainable production, the fact that we're not using such a mass amount of water to reduce fiber packaging, we are actually getting closer to that circularity and that sustainability.
Also, the environmental footprint counts more and more from my perspective. What I hear from talks to customers and to people related to packaging, it's more and more important.
What about the machine itself? I know some of your other ranges have a very modular approach when it comes to tooling. Is this the same on your dry fiber machine, the DFM 100?
Not really. Of course, we try to transfer all the experience we have in thermoforming machines to dry fiber as well. So you have a very modular machine. You have an HMI, which is kind of which customers are kind of used to. We adapt quick tool change technologies to the machine, that also the machine can have more uptime a year, and is not stopped by tool changes or maintenance so much. So these are the things that we do in thermoforming since decades, and what we transfer to the dry fiber approach as well, of course. Tooling is a little bit different because we have a form press process with a male and female forming tool, which is different to thermoforming, because dry fibers are like a loose web. You can imagine, which is formed by geometrical contact to a tool surface, not by vacuum or air, because it's not leak tight, of course. And therefore, we had a different approach in the tooling, which we had to develop completely new in the recent years. But on the other hand, I think a process engineer of thermoforming will get to know very fast how it's working and get into the process specification, and will adapt very fast to dry fiber processing. Because at the end, there's a packaging form part as a result, and that has a specification for the use in practical supermarket or point of sale. And this is the same like for a plastic form part. So the result counts in that case, and I think the process is just the path to get the result.